Okay, if you look into this circuit, I mean not circuit, it's a inductor element, inductance, which has some inductance L. Now a time varying current is flowing through the inductance. Everybody will know VAB equals to L into di of t by dt. As current is time varying, of course flux will be time varying. Flux produced by this inductor will be time varying by this coil. Okay, now the main motto of this video is, we know that resistance of any material is rho L by A. Okay, where rho is the resistivity of the material and L is the length of the winding material and A is the cross section area of the winding. Suppose if you take some material like this resistance material, it will have some length. It is after all a coil. Okay, now the important point here is resistance is independent of the amount of current flowing through it. You may pass whatever the current might be, but here the amount of current, whatever the current might be, here the resistance is independent of the current. That's the physical importance you can conclude from this equation. In the similar lines, you have to know the physical importance of inductor. So in order to know the physicality of inductance, I am taking some magnetic material like this, and I am wound n number of turns here, and I am feeding some time varying current here. Now of course a time varying flux will be produced phi of t. Time varying flux will be produced phi of t. Now according to definition, L, inductance of the coil, is nothing but total flux linkages per unit current per unit ampere. So as here n number of turns are there, so total flux linkages would be n into phi over I. We know that B is equal to phi by A, where B is the flux density. So phi equals to B into A. Therefore inductance L equals to n by I into BA. Okay, now one more important thing, one more important relationship. We know that B equals to mu naught mu r into H, where H is the magnetic field strength. Now if I include this statement in the previous equation, so L equals to n by I into mu naught mu r H into A. Now from Ampere circular law, we know that closed integral H cap dl cap is equal to n times of I unclosed, where n is the number of turns. And if you see here, I and L is in the same direction. So if you are strong in electromagnets, you would understand this. So H into L is equal to n into I. So as H and L is in the same direction, this integration will be H dot L. The dot product, simple dot product, will be H dot L. Now anyway, now H equals to Ni by L. Okay, now if I include this statement as well in the inductance part, so it will be n by I into mu naught mu r into H is Ni by L into A. Now this I would go cancel, so this is simplified as mu naught mu r n square A by L. So this is the final inductance formula. So the similar analysis as like resistance, here if you look into this inductance value, it is also, inductance also independent of the current flowing through it. It is also purely dependent on the physicalities like number of turns, area of the cross section, and mean length of the flux path. So the take point here is inductance is independent of amount of current that is flowing through it. And one more important thing is, if you keep mu r as constant value here, once if the physical construction is done, the number of turns, cross section area, mean path length would be almost constant, always constant, and mu naught is depending, it is also constant value. So mu r depends on the relative permeability. If you keep relative permeability constant, inductance value would occur constant. So this inductance, if inductance is constant, then it will result in linear BH curve. Okay, anyway, the important thing is L mainly depends on mu naught mu r m square A by L, and it is independent of the amount of current flowing through it. This is the important physicality of inductance. Thank you.